Question 2, Part B. Use the binomial theorem to find the term independent of x in the expansion of 2x minus 1 over x squared in brackets to the power of 12. The term independent of x corresponds to the constant term in a binomial expansion. What we want is the constant term in the expansion of 2x minus x to the power of negative 2 in brackets to the power of 12. Notice that I wrote the second term in the binomial using a negative index. Now this will help later on when we locate the position of the constant term in the expansion. Now recall that the general term or the rth term of a binomial expansion, a plus b in brackets to the power of n, is given by tr is equal to n choose r times a to the power of n minus r times b to the power of r, where r is an integer greater than or equal to 0 and less than or equal to n. In this case, a is equal to 2x, b is equal to negative x to the power of negative 2, and n is equal to 12. Hence, tr is equal to 12 choose r times 2x in brackets to the power of 12 minus r times negative x to the power of negative 2 in brackets to the power of r. So expanding the brackets here and here and putting the numerical components over to one side and the term involving x over to the other, we could write it like this. tr is equal to 12 choose r times 2 to the power of 12 minus r times negative 1 in brackets to the power of r times x to the power of 12 minus r times x to the power of negative 2r. Now we get this term here using one of the index laws, the power to a power law. Notice that this negative here has ended up here, and the 2 and the x here has been broken up as well. So this 2 is this 2 here, and this x to the power of 12 minus r, is this x here. Now, if we want the term independent of x, we want these two terms to disappear. So we want to find r such that 12 minus r, which is this index, plus negative 2r, which is this index here, to equal 0. Since we're multiplying two terms with the same base, we add the indices. So we want the sum of these two indices to equal 0. Now in this case, r is equal to 4, solving for r here. Which means that T4 is equivalent to our constant term. So T4 is equal to 12 choose 4 times 2 to the power of 12 minus 4 times negative 1 in brackets to the power of 4. Now this term here is positive 1, so we can discount that one. So that equals 12 choose 4 times 2 to the power of 8, or 126,720, which is the term independent of x.